All right, hi there. In this video, I'm going to show you how you can move an I2C device, which is what we have here. This is our little LCD screen, and it's just displaying the time in milliseconds since the code started running, 200,000 milliseconds ago. And I'm going to show you how you can choose an alternative clock and data pin on the Teensy 3.2, for example, or 3.5, 3 point something. This one's set up to the default A4 and A5, and if you don't know how to set this up, look at the previous video, which is in the description below. All right, so let's go to the code where we started, and up here at the top, right, we can see there's a link here to the Teensy pinout. We were on the 4.1, so now let's scroll down to the 3.2, which is what I've got here. So the 3.2, notice that the A4 and the A5, or the SDA and the SCL, the data and the clock pins, respectively, for the default I2C port. So let's take a look at that more carefully here. All right, and you can see that my yellow wire here is plugged into A4, the signal pin of A4, and my blue wire is plugged into A5. And the yellow wire here is the SDA, the data, and the blue is the clock. Okay, but let's pretend, for example, you have like this real-time clock and it's plugged into the main one, and you can build your own little breakout board on a breadboard like this, or use a circuit that I built. If you're one of my students, we have that circuit. So let's say you don't have that. How can you run this LCD on a secondary port? So I'm going to just unplug these, all right, and let's take a look at where that secondary port is. So if we look here, the SDA, the data file, is A3, and the clock file is A2. Again, we're on a Teensy 3 point something, all right? So data is A3, clock is A2. So let's connect that. Data is A3, clock is A2. All right, so A3 is here. And as soon as I plug it in, you see it's got power and ground. And then the clock is A2. Oops, sorry, I missed it. A3 and A2. Okay. And if I upload this code again, it's not going to work, obviously, because I'm on the default pin numbers. And you can see I just get this bar here. And this is why this can be kind of frustrating. This bar is also what it looks like when your board is not the right brightness setting. So you might be tempted to turn over here and adjust the little pot to get it to work, but it's not working because we're not using the right port. So let's make that happen. Okay, so let's use the alternative port. And this can only work with the Teensy 3.2, 3.5s. So everything stays the same. Okay, and I should mention up here, so for multiple I2C devices, there are a couple of options for the Teensy 3 point whatevers. You can use pins 17 and 16, which is pins A2 and A3, as we said. So we scroll down and uncomment these to use the alternate I2C. So I'm just going to highlight them and uncomment them. So now I've created this variable called SDA pin and SCL pin. You don't need to do this if you're using the default ones, the default pins. You also need to uncomment the wire command. This is inside the setup function, and this sets up the SDA pin and the SCL pin. So now we upload the code. If you remember, there's a while bang serial line here which says to pause until the serial monitor is opened. All right, so I'm going to kind of move that over here. As soon as I open up the serial monitor, you should see the welcome screen here. Hello world, start me up, okay? And then the code starts printing the time. And so there it is. That's all there is to this tutorial. Once again, we are using the alternate pins in case we have something plugged into the default pins. And hope that was helpful. So in the next video, I'm going to return to the Teensy 4.1, and I'm going to show you how to run two LCD screens simultaneously on the same I2C bus. All right. Until then, I'll see you in a bit.